Assalamu alaikum. Today we will solve the linear programming model through specified software for the linear programming, and that is TORA. In the last classes so far, we have solved such of the linear programming model by two methods. One is graphics, and other is simplex method. And for graphic and simplex method, we have used Excel sheet. So we can use another software just like TORA. In the other video, I've shared the link over there. You can find, download, and install that TORA. And if you have already done it, you have already installed TORA, so you will be very well aware of this screen. So now I'll be solving this problem of linear programming through TORA, and then we can go for the for some complex model and other kind of analysis. So this is the question, this is the problem, and what kind of problem is this? You know very well. This is about maximization, subject to some constraints. And if we are given the objective function, if we are given the constraints function, obviously we can solve these question through TORA. So first of all, I have to be very clear about my number of constraints and number of variables. So here in the problem, I am having two variables, x1 and x2, and I am having two constraints. So two variable and two constraints, keep it in mind, and I'm going to TORA. I'm just clicking here where it is written, click here. And now here I'll be going for the linear programming right now, because we are learning the linear programming model. So that's why I'm not detailing all of other problems. I'll explain it when time comes, but here I am doing right now the linear programming. I'm just clicking linear programming, and just go to input screen where I have to put the basic information. I'm just clicking go to input screen, and here he is requiring us that the problem title, we can give any kind of title. Let's say I'm giving the title here, Zishan problem number one. Problem number one. And he's asking about the number of variables. We know that the number of variables are two. I have pressed 2 and press the enter. Then number of constraint. I know that the number of constraint here, it is given that the constraints are also the two. So here I'm going again. Sorry, not here. Here. So here the information is given to the system. So we have two variables and two constraint, and now just clicking enter, uh, pressing enter, I'm getting this kind of a screen. So now the same problem or same kind of framework of that linear programming has been established, just like here. And but here the values are given, and these values, these constant, these ratios, here in the box, we have to fill it with the basic requirement. Now, variable name, we can put any kind of name over there, a b c x y z, whatever. So here in the question I am having x1 and x2. So here x1 and x2, I'm giving them the name x1 and x2. And after that, here the question is to maximize. By clicking here, you can find both of the objective. You can find minimize, you can find maximize. And you can see that I'm just clicking this tab, and the both options are coming here. So you have to be very clear about your objective. And here in the problem, my objective is to maximize. So I'm going to click on maximize. So it is maximize. And now the objective functions coefficients are 5 and 3. Here you can see that the 5 is the coefficient of x1 and 3 is the coefficient of x2. So 5 and 3 are the values. So here I am putting the 5, and here it is 3. Objective function coefficients are given here. Constraint number one and constraint number two. Now I have to put the constant from the constraint number one, 3x1, 5x2. So it is 3x1 and 5x2. And here I have to choose the sign. Either it is less than, more than, or equal to. You must be having some clear instruction from the problem. Here I am given the sign of less than and equal to, and here the less than and equal to sign is already given. But if you want to change it, you can change by pressing shift and uh, 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 greater than. Now you can see that the shift and greater than sign is changed, or if you want to change it, you can change it by shift and less than. So shift and less than, shift plus less than, you can change the sign here. And if you want to put the equal, just press equal sign directly. So you can find equal sign directly as well. So here the sign in the both constraint is less than or equal to, so I am pressing less than or equal to for the both constraints. And on the right hand side, the values are given here, 15 and 10. 15 for the constraint number one, that is 15, and 10 is the constraint number for the constraint number two. So that is uh, uh, given to the cell. And now you have to put the enter, because this is the last constraint. So the pressing enter is necessary. So I've put the enter button. Now the basic information is being given to the software, and now you can solve through both methods, through graphs and as well as through uh, simplex again. So I'm going to solve menu. Uh-oh. All left hand side coefficient of constants are zero. uh, Let me see what is saying that. Okay, constraint number two, the values of constraint number two is not given here, so I would be going to again my problem, and here is 5 and 2 are my constraints coefficients. So 5 and 2, this is 5 and this is 2. So now the basic information is completely given to it. We can confirm it, 3552. So 3552. So, okay. So the information is now complete. Now we can go to solve menu. We are asked to save this particular question. You can save it if you want, and if you do not want, so it is not mandatory. So I'm not saving it right now. Now, here the options are given to solve problem and solve problem through graphic method or algebraic method. And if you want to view or modify input data, if you want to change something from the data, so you can do it from here. And you can go to the main menu where a blank sheet would be again visible for you after that. But I'm going to solve the problem, and I'm going to solve through graphicals. And we have already solved such kind of a question through Excel sheet in the graph. So but here we will be seeing the graph from the TORA. I'm just clicking the graphicals, and I'm going to the output screen. Go to the output screen. I'm clicking it. Now this is simple plain graphical surface, and here the complete information or complete problem is being given. So if I am clicking to the constraint number one, you can see that the constraint number one have drawn the straight line. It is the same straight line which we have drawn in the Excel sheet. And if you want to get another constraint, just click on the constraint number two. You will find the constraint number two. And where is our solution? As I told you in the Excel sheet, our solution set is on mostly on the corner, and we have to go to the maximize our objective. So by clicking this maximize option, you can see that the objective line is being drawn, and it has been covering the upper side of all the values, or to have the maximum range of the given feasible solution sets. So this is actually the optimum solution. And now here you can see only the graph. You cannot see the solution set. Uh, so I think there should be, there it is the solution set, but unfortunately the screen is not showing this thing. But anyway, we can this is the graphic solution, and we can see the objective value 12.36. So this is the maximum value of the this function 12.36, but the value of x1 and x2 are somewhere hidden here. So for that we will go to another method, that is algebraic. So I'm going to view or modify input data again. So this is our basic question. I'm going to solve menu again. I'm not saving it, and now I'm going to solve menu and with algebraic solution. So in algebraic solution, there are two other options. Either you want to iterate, either you want to see the iteration. Iteration means the all boxes what we have solved in the simplex method. If you remember that while solving the simplex method, the table was repeated and formulas were applied. So those kind of a series of that table is called iterations. So if I go to the iterations, all slacks starting solutions, I'm just following this method, simplex method. I'm just doing it here by selecting all slacks starting solution. So I'm going to the output screen. So you can see that the same table is being again drawn, but here you can see that the formulas have been applied. But if I'm going to the all iterations, you can see the all iterations are there. So iteration 3 is optimal. So these are the maximum iterations. These are the same tables where we have applied the formula of the simplex, where we have operated the row with the rows, and all kind of those tables which was repeated in the simplex method, that is being explained and solved here in easy form. So you can see the solution set in the iteration number 3. So iteration number 3 is giving you the solution. Our solution is the objective function value is being maximized at the 12.37, and while the here it is x2. You can see here uh, x2 is having 1 and x1 is 0. So x2 value is 2.37 and x1 value here is okay, I should not click on it. Here you can see the value of x1, it is 1, and against this 1 value, the value of 1.05 is the solution value of x1. So maximum z value is 12.37 is concluded, x2 is 2.37, and x1 is 1.05. That is the main solution for the problem. And this was the algebraic and iterations. So now I'm going to again to my main problem, and I'm again going to solve menu. I'm not saving it, and now I'm going to algebra and final solution. So this is actually the solution where you have to focus, and you have to explain some analysis. So I'm just going into the final solution. It is final solution. Go to output, and this is your output screen. You can see that output screen will reveal four different kind of columns. One major column is variable. Uh, 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 then the other is constraint, and you can see again the variable and constraints are being repeated. But the first part of the variable constraint, the upper part of this sheet is giving you the basic solution, where you can see that the x1 is having final value of 1.05, as we have concluded in the graphics and as well as in the simplex method. So x1 value is being concluded at 1.05, x2 value is being concluded to 2.37, and in the objective function, if we see that the x1 value is being multiplied by 3, because x1 one unit of x1 uh, possessing the value of 3. So this information is uh, explained here again. Let me see one thing. Yeah, x1, 1 unit of x1 is being priced by rupees 5, and x2, 1 unit of x2 is being valued by 3. So 5 and 3 are the basic objective coefficients. So here 5 and 3 is given. So objective coefficients is 5. The final solution value of x1 is 1.05. It means that by following all these constraints, the maximum value of z would be, here you can see the 12.37, and that 12.37 would be achieved by having x1 by 1.05 and x2 by 2.37, and x1 point 1.05, if it is being multiplied by the 5, so it becomes 5.26. And if x2 final solution value is 2.37, and if that is multiple of 3, so that becomes 7.11, and this 5.26 and 7.11 are, if being added or summed up, so they become 12.37. So that is our basic solution values. uh, and here the constraints are given: 15 RHS and 10 RHS, right hand side values. But here you can see a slack and surplus. Now, what we mean by slacks and what we mean by surplus, I'll be explaining in the next question. But here you can see the values of 0. And the lower part of this screen is showing you the sensitivity analysis. So what the sensitivity analysis, and again I'm telling you that I'll be explaining this sensitivity analysis and as well as the slacks and surplus in the next question. But now, for the sake of getting understanding, you have to solve at least minimum 3 questions just to have this kind of a screen as solution in the assignment. So this is all about the Torah. You can find the other video, other link that has been given to you. You can download Torah software. You can install, and after that you have to solve at least 3 different questions by putting these values and having this kind of a screen. And after having these screens, then I'll be explaining all of the basic information given in the results. So we'll meet in the next session. Thank you very much.